On the pink, yes. Bruno, copy. You're plugging in your phone. You're going to die. Plug in your, copy this. I am not worried about your phone. Can I what? I did make it bigger. How? I don't think I can. Is that big enough?
Do we have to write everything or can we write the...
Yes, write the stuff down. That's why I put it there. I said copy it. Is this bigger?
Yes.
Okay. Yes.
Yes.
Good.
Oh, we don't have a quiz today, huh?
I don't know. We'll see. Get the earbud out of your ear.
You said we were done, though, yesterday.
No, I said if you behaved. Did you copy? That's why I'm having to be mean. All right. So when there's cosines on both sides and we have the +3, I need to get all the cosines on one side. So I'm going to subtract . And then I'm going to divide by 2. So if I want to get the x by itself, what's the inverse of the cosine? Or the inverse? So what I want to know is, where is the cosine equal to the square root of 3 over 2? All right. So if the cosine is at pi over 6, and that's the square root of 3 over 2, where else is the cosine positive, and it would be equal to the square root of 3 over 2? So it's x is positive on this side, right? So it would also be positive down here, right? So when we do this, this is our alpha. If we want it in this quadrant right here, this is going to be pi minus alpha. This is going to be pi plus alpha. And this is going to be 2 pi minus alpha. So you just told me the cosines are positive on this side, right? So I would use my alpha and my 2 pi minus alpha to find those answers. So what if I wanted to know where my sine was positive? Where's the sine positive? These two, right? So I would use alpha and pi minus alpha for these, correct? What if I want to know where the sine was negative? It'd be these two, right? So I'd use my pi plus alpha and 2 pi minus alpha. Does this make sense? Okay. What about tangent? Where is the tangent positive? Tangent is y divided by x. In the first quadrant, and where else do I get a positive answer for tangent? In the third. So these two give me positive tangents, right? And where would give me a negative tangent? These two, okay? So that's never going to change. Those are always going to be the same. So if I get my first one is pi over 6, I know. Then I want this one, which is going to be 2 pi minus pi over 6. So you need the common denominators. which would be 12 pi over 6. Which would give me 11 pi over 6. So I got two answers, both where the cosine is positive. So the next one is going to be when I have to take the square root. When I have to take the square root. So the first thing I'm going to do is add the 4. And divide by 3. Now if I just want the tangent by itself, how do I get rid of the squared? I'm going to take the square root. So if I take the square root of 4, what's the answer? What about negative 2? Is negative 2 times negative 2 a positive 4? So a positive 2 times a positive 2 gives me 4, but a negative 2 times a negative 2 also gives me 4. So I don't know which answer I want. So when I take the square root of this, I don't know if I want the positive or the negative, because they both end up positive. So I'm going to get the square root of this. So it is, so then what we have to do, what is the square root of 1? And then can I have the square root of 3 in the denominator? What do I have to do? I'm going to have to rationalize it, right? So I have so this is going to give me the tangent of x equals plus or minus the square root of 3 over 3. So I know where the tangent is 1. That's at pi over 4, right? So one tangent is the square root of 3 over 3, and the other is the square root of 3. So somebody look on your little table. I think it's pi over 6. But somebody double check before we do the whole problem wrong. It's on the blue notes. Pi over 6? Okay. So this is going to give me so I know that the answer here, the positive answer, pi over 6. So so the other place you told me tangent was positive is down here. So that would be pi plus pi over 6, right? So that one, 7 pi over 6. But I also need a negative. So that's going to give me this in this quadrant. So this quadrant is going to be pi minus pi over 6. So that's going to give me 5 pi over 6. And this one is 2 pi minus pi over 6. That's 12 pi over 6 minus 1 pi over 6. Gives me 11 pi over 6. So we end up with 4 answers that time. But really, all you needed to know was the pi over 6, right? Once you have the pi over 6, you just need to know, I want the positive and the minus. Right? We needed all 4 of them. Does that make sense? Okay. So the next set we're going to do are solve by factoring. I know factoring is your favorite thing to do. But really, I'm just going to start. I'm going to move the square root of 3 sine of x to the other side. I know how to do it, so I don't need to write it down. So what do the two things have in common? Sine of x, right? So I'm just going to take out a sine of x. So before I go any further, I want to ask you, if I'm solving this, what are my answers? And how many answers do I get? 2. What are they? 5 and 0, right? Because this is an answer. This, if I make this equal to 0, that makes the whole thing 0, correct? In this, if I make it 5, the whole thing is 0. This is going to work the same way. I have to set this equal to 0, and I have to set this equal to 0, because they both will make the whole thing 0. So I'm going to end up with so where on your little unit circle does sine equal 0? Here and here, right? So these are both 0 for sine. So x here is 0 and pi. And this one was just like the first one we did, where I'm going to add the square root of 3 and divide by 2. And I get this by taking the inverse. So I want a positive cosine at the square root of 3 over 2. So cosine is the square root of 3 over 2 at pi over 6. So where else do I get a positive cosine answer? Down here, right? Because these are the positive x's. So it's down here. So that's 2 pi minus pi over 6, which is 11 pi over 6. So everybody's okay? Yeah. It's not bad. It's a lot of writing. Okay. It's right there. All right. Okay, I want to do this one. This one over here. Okay, so before you even start this, if I replace the sign with an X, so I had, and I ask you to factor, how would you factor it? You do the A times C and the B, right? And if you did that, and you did it successfully, you would have 2x and x. And then we'd have the plus and the minus 1, right? Those are at the end. And then I want my x to be positive, so I'm going to make this one plus and this one minus. Yeah. Okay, so now replace the x with the sign. So I'm going to have 2 sine of x minus 1 and sine of x plus 1. And then we're going to set each of those equal to 0. Tuesday. Yes. Okay. So where is the sine of x 1/2? Okay. So on my little handy dandy unit circle, I'm at pi over 6. And this time it's sine, so that's my y value. So I want a positive 1/2. So where is sine positive? In the top. So how do I get this answer? Very good. Pi minus pi over 6. And that's going to give me 5 pi over 6. And the last one, where is the sign -1? So that's where is my y value -1? Bottom, so it's at 3 pi over 2. So all three of those are your answers. Because it's -1 down here, which is 3 pi over 2. All right. We're going to come back and do that one. I'm going to move on. We'll come back and do that. All right. So the next set we want to talk about is when we can divide. So sine of x equals cosine of x, you can divide. Sine squared of x equals sine of x, you can't divide. When they're different, you can divide. When they're the same, you can't divide or you lose a term. So this one, it's okay to divide. This one, you have to subtract. Okay, and I'm going to show you, I'm going to do both of them, and I'll show you why you can't divide. So let's start this one. Let's divide both sides by cosine of x. Okay, so that's a great question. So he wanted to know, why did I divide by cosine of x? Because when I looked at it, what is sine over cosine? If I went the other way, if I divided by sine to move it the other way, then it's cotangent. Do you know the values of cotangent? But do I know the values of tangent? Yes, or at least we know where to find them on our little chart, right? So that's why I did cosine. So what is cosine divided by cosine? 1. So I get tangent of x equals 1. So where does tangent of x equal 1? Pi over 4. So my x is pi over 4. So that gives me a positive tangent, correct? Where else on the unit circle do I get a positive tangent? This one? So this one is going to be pi plus pi over 4. So that's 4 pi over 4 plus 1 pi over 4 gives me 5 pi over 4. So look at this one. If I divided by sine of x, I would get 1 on this side, and one of the signs would cancel out, correct? So I would just end up with the sine of x equals 1. But here's how, these are the answers, and so let me show you why you can't do that. If I subtract this, and go ahead and write this one down, because this is the way you're going to do this. If I subtract this, do they have something in common? The sine of x. And now how do I get my answers? Set them both equal to 0. So this is what we would have gotten if I would have canceled, but what would I be missing? I'd be missing this one, wouldn't I? So I wouldn't get all the answers. So if these match, like the sine squared of x and the sine, you can't divide. But if they're different, you can divide. If you can cancel, if you can change it to something else, okay? So here, where is the sine of x? 0. Pi and 0. And where is the sine of x? 1. Is there another one? But down here it's -1. So it's just 3 answers this time. And we only would have ended up with 1 if we would have canceled. All right? So you don't want to cancel. Yes?
So when they're the same, you subtract them?
Yes. Yes. And then factor out. Yes. But I put them together in here under division because the most common mistake you make is dividing right here. And so don't do that when they match, okay? But when they're different, you can divide. Okay, so now I have the secant of x plus 2. So first of all, a lot of you don't like it because you don't know what the secant is. So I'm going to subtract the 2. I know. What? Okay. So I'm subtracting the 2. So then, here's what I know. I know the secant is the reciprocal of what? Cosine. So instead of having the cosine of 2, the secant of 2, that would be the same as the cosine of what? What do I have to do this if I make this cosine? -1/2, right? So can I do the cosine? So where is the cosine of -1/2? First of all, where is the cosine 1/2? Pi over 3? So it's positive at pi over 3, right? I don't want positive, I want... So where is my cosine, where are the x's negative? These two, right? So if my alpha is pi over 3, I need these two. So this one, I'm going to take pi minus pi over 3. And this one, I'm going to take pi plus pi over 3. So my answers are going to be 2 pi over 3 and 4 pi over 3. Because this would be 3 pi over 3 plus 1, which would give you 4 pi over 3. Or sine, whichever one, wherever, anytime you want to be in this quadrant, you're going to take pi minus. Anytime you want to be in this quadrant, you're going to take pi plus. And anytime you want to be in this quadrant, it's going to be 2 pi minus. Okay, one last example. So the difference of squares. So 4 cosine squared minus 1. So if I was going to factor this, what would it look like? It's a perfect square. And if you get confused, write this. 4x squared minus 1. How would I factor? So I would factor it 2x plus 1, 2x minus 1, and just replace the x with cosine. And you have to set both equal to 0 then. So where is the cosine negative 1/2? So let's start with the positive one because we know that's in the first quadrant. So cosine of 1/2 comes at, oh yeah, pi over 3. So my other one comes here, which is 2 pi minus pi over 3. So this is going to be 6 pi over 3 minus pi over 3 gives me 5 pi over 3. And then how do I get to my negative x's? Pi minus pi over 3. So pi minus pi over 3 will give me 2 pi over 3 and 4 pi over 3.